All right, let's dive in. Today we're talking about a super powerful type of AI that is kind of quietly, completely changing how we make things. And look, this isn't just about making robots move a little faster. This is about making them smart, truly adaptive, and able to learn things all on their own. But how in the world do you actually teach a machine to think for itself, especially in a place like a factory, which can be messy and unpredictable? Well, it all boils down to this one really simple but kind of profound question. How does a machine learn from its mistakes? The answer is a field of AI called reinforcement learning, or RL for short. And what's cool is that this whole idea is basically borrowed from psychology. Seriously, think about how you'd train a puppy. You give it a treat when it does the right thing, right? That's a positive reward. And pretty soon, it learns to do that thing more often. RL works on that exact same principle: trial, error, and reward. At the heart of it all is this beautifully simple learning loop. First, the AI, and that could be a robot arm or even just software, it perceives its environment. It looks around. Then, it takes an action. Based on what happens, it gets feedback, either a reward for getting closer to its goal or a penalty for messing up. And then, the most important part, it learns from that feedback to make a better choice next time. It does this over and over, thousands, even millions of times, until it develops the best possible strategy, or what the pros call a policy. So, okay, that's the theory. It sounds cool, but what does this abstract loop actually look like on a real factory floor? Well, let's take our first example, teaching robots how to weld. The old way of doing this was pretty rigid. A welding robot would just follow a pre-programmed path, move for move. But what if the metal pieces weren't perfectly aligned? Which, by the way, happens all the time. The weld quality would just tank. With RL, though, the robot becomes adaptive. It's not just following a script anymore. It's actually making decisions in real time. And check this out. This is where it gets really specific and really cool. A team of researchers, Pentilla, Lund, and Skriko, built this amazing welding system. It uses laser sensors to literally see the condition of the metal seam as it's working. It's measuring the gap, the face, all of it. And based on that Rive data, the RL agent instantly tweaks the welding current, the voltage, and even the robot's speed to make sure every single weld is perfect. And this quote just nails it, doesn't it? The system isn't just automated, it's dynamically adapting to the real world. That's the superpower of RL. It can handle the complex, messy reality of an industrial process. But hold on, because RL isn't just for physical jobs like welding. It's also being used for some seriously high-level cognitive work. It's actually changing how we design the technology that powers our entire world. We're seeing this fundamental shift, AI is moving away from just following orders and is becoming a genuine partner in engineering and design. I mean, take the mind-bogglingly complex process of designing a computer chip. There's this one critical step called optical proximity correction, or OPC. Traditionally, this was all up to human experts with decades of experience, and it was a really slow trial-and-error process. But now, research from Chen and his team shows that an RL agent can just go in, explore the entire design space on its own, and rapidly find these optimal recipes for chip layouts that a human might never even think of. And its impact is just spreading like wildfire. We're seeing RL pop up all over manufacturing. It's creating these super flexible robotic workflows, it's making machining and cutting smarter, it's powering predictive maintenance, it's even making it safer for humans and robots to work side by side. Now, as exciting as all of this is, let's get real for a second. Putting RL to work in the real world, it's not exactly a simple plug-and-play situation. There are some pretty big hurdles that researchers are still working hard to clear. The first huge challenge actually goes back to that reward signal we talked about, the little treat for the AI. What happens if the AI has to do a whole long, complicated series of steps before it even knows if it did a good job? What if getting that reward is a super rare event? This is a classic issue known as the sparse rewards problem. Okay, imagine trying to solve a gigantic maze, but the only clue you get is right at the very end. Someone just tells you, you're done. How would you ever figure out the right path? It would take forever. That's exactly what it feels like for an RL agent trying to learn a complex task with almost no feedback along the way. So, to get around this, researchers are teaching the AI to learn smarter. One really cool technique is called curriculum learning. Basically, you start the AI on an easier version of the task and then gradually crank up the difficulty. It's like starting with training wheels.
Another strategy is to encourage more focused, less random exploration, which helps the agent stumble upon those rare rewards way faster.
So, learning efficiency is one thing, but there's an even bigger, more critical challenge, especially when we're talking about giant, powerful robots moving around: safety. I mean, think about it. An AI that learns by trial and error cannot be allowed to make dangerous errors in the real world. So the solution is to bridge what's known as the sim-to-real gap. This means the AI gets trained like crazy in a super realistic computer simulation first. Then, when it's finally deployed, it's often part of a hybrid system where a human can step in. And it operates inside these special risk-aware frameworks that literally prevent it from trying anything unsafe. So, when you put all of these pieces together, you have the adaptive learning, the cognitive partnership, and all the solutions for safety and efficiency. This truly incredible vision for the future of manufacturing starts to come into focus. Because the ultimate goal here, it's not just about having more automation. It's about creating factories that are truly autonomous, systems that don't just follow a list of instructions, but can perceive their world, learn from it, and adapt to brand new challenges all by themselves. There's actually a name for this whole concept. It's called embodied AI. And it's this convergence point, right, where advanced artificial intelligence, the brain, gets connected to physical robots, the body, that can actually sense and act on the physical world. The brain is finally meeting the body. And this, right here, is the key takeaway. Reinforcement learning is not just some small incremental improvement. This is a foundational technology. It is paving the way for the entire next generation of smart manufacturing. It's a whole new industrial paradigm, a true revolution powered by machines that can learn. Which leaves us with one last kind of fascinating question to think about. We're already seeing RL master these incredibly complex tasks, from welding to designing computer chips. So how long will it really be until our factories can truly run and improve themselves?